Steve. So I come from TellApart. We recently, just a few months ago, started using Aurora and Mesos basically to transform our infrastructure from really a monolithic single application into like microservices. And really, I just want to talk about like what we've done and really go into some of the work we've done with Docker and integrating it with Aurora and some of the fun we've had there. So what is TellApart? Probably many people don't know about us and what we do. Basically, we're a data platform that e-commerce companies come to us, and we basically help them find the best, most valuable customers for them. So what that really turns into technically is we bid on major ad exchanges, so Facebook, Google, OpenX, all those things, and bid for them on ads. So when you go to Facebook, sometimes you'll see an ad of like somewhere you've just been, Nordstrom or something like that. That's basically us. So as part of that, we really have a tight feedback loop between ingesting data and having to process it and make decisions on it pretty much in real time, which brings some fun scalability problems and things like that. And so I'll get in later of how Aurora is helping us solve a lot of those things. So one of the things we say at TellApart too is we don't have really big data, we have fast data. So kind of just some metrics of what we're doing. We're getting 200 terabytes a day of logs coming in uncompressed. Basically, at any given point, we're running around 300,000 requests a second into our applications. And really, when we're getting bids in from the exchanges, we have to have really just a couple milliseconds of time to respond on what we want to bid. We're all in AWS, so we have around 2,000 instances right now. A good amount of those are Hadoop instances doing MapReduce, but a good chunk now are actually Aurora Mesos slave nodes, which is pretty awesome. And across all that, it's run by 47 engineers. So the scalability of people here is really the most important thing that we're trying to solve. So basically, where we are right now at TellApart is the same place Twitter was a while ago, actually. We had one large application. We called it Taffy, TellApart front end, similar to Twitter front end. And we're in the process of really splitting that up and moving it into smaller microservices that can be deployed independently and on their own and developed by different teams. So one of the big problems we ran into in trying to do that is that, okay, well now we have all these applications that need to be deployed on their own. And the classic style is like, okay, well, I write some deploy scripts, I build some servers for them, I deploy them, and we rapidly realized that that's not going to work. Like, you can't scale that across more than like 5 or 6 services because it's just, you're wasting developer time doing that. Like, they shouldn't have to worry about how am I going to deploy this application, how do I write a build script, how do I provision servers in AWS. So we started looking, what are we going to use, how are we going to do this? We came upon Aurora and Mesos and really liked what we saw there. So we really ran with that pretty quickly. We started around November, and by the beginning of December, we had already moved a good chunk of our production bidder traffic into Aurora, which is a pretty big milestone for us. So why did we choose Aurora over other things? We had considered Marathon a little bit. It turned out it wasn't really a great fit for us. One of the big features that we loved in Aurora was the beta updater, the new server-side updater, which we have almost 100% positive feedback from all our developers. Like, it's awesome. It really, just the UI there is really great, and it makes it so you don't really have to worry a lot about like, how's this update doing? How's this update doing? Or like, is it healthy? It manages all that for you. So it really removed a big chunk of like our rollout time of do a canary, test it, see if it works, all that stuff, where the updater really solved that for us. So the other thing is just like we really did like the web UI that it had. It's really easy to see like what's the state of all my jobs, what's going on at the time. And then there are other alternatives too, like AWS has the EC2 container service, but that was kind of in a really early phase at the time when we were evaluating this, and it doesn't give us all the control we wanted that we would get from something like Aurora or Mesos. So what are we using it for right now? And also, by the way, if anyone has questions while I'm going through this, feel free to stop me. I'm happy to. Yeah, what's up?
Are you running Mesos on AWS?
Yes, we are.
Repeat the question.
Are we running Mesos in AWS? And we are. So we actually had a couple patches that I had submitted early on to make it a little more AWS friendly with host names and things like that, but everything we run is in AWS. So we spin up EC2 instances on demand. I just started 25 a couple hours ago to start running some new jobs because we needed some capacity. So the combination of that is really helpful for us. We can add and remove capacity pretty much as we need to. It also makes rollouts of Mesos slaves really easier if we need to upgrade or things like that. So what we're running now, we have our bidder, which is a Java application, running 100% right now through Aurora, which is awesome. This is basically the bottom line of our business right here, and basically it's what makes us money. So we recently, thanks to Thanos and a couple people over there, just transitioned the last network that we had into Aurora, which was a big milestone for us, and we were really happy about that. And so that's running around 150,000 requests a second across, I think, 40 or so tasks in Aurora. So that's pretty awesome. One thing that I'm actually going to talk a lot about in the next slide is something we call OR proxy, which is basically our solution to load balancing inside of Aurora. So one of the problems we run into is everything's running dynamic ports, everything's running on many possible nodes. So you need a way to route traffic from the outside internet into your network. So again, Thanos built something we call OR proxy, which basically watches Zookeeper and dynamically configures Nginx to route traffic to nodes as they come up and down. And that's actually something we're planning on open sourcing pretty soon, which should be pretty awesome. We also have a bunch of microservices. Some of them are Docker containers. Some of them are just normal Java services that we run. So we probably have 200 or so tasks running the supporting things like logging, collecting VARs, things like that. And then our next big push is our Python applications. So this is really where Docker comes to shine because it can help us isolate all of the Python applications from each other. Some of them have different requirements. Some of them have different dependencies, things like that. So our front end, which runs around 30,000 QPS, we're basically tomorrow going to be moving fully into Aurora. So that's pretty awesome for us. So this is just a nice diagram of our traffic flow. So traffic comes in from our ELBs, or from the internet, goes to our ELBs, which are basically, at this point, just dumb routers. They don't really do anything. They usually have a couple nodes in them. And it moves all the traffic into our OR proxies, which are just normal Aurora jobs running on some slaves. We run around 5 or 6 of them, depending on the traffic profile. And then those, like I said, are watching Zookeeper and dynamically rewriting the Nginx jobs as they go. So this is really, like I said, the key to our infrastructure, and it helps us very reliably keep traffic going through our cluster. Even as jobs go up and down, we basically don't notice. So we can do a rollout in the middle of the day, don't lose any traffic, nothing happens. So this is great. This is actually one of the big problems we had to solve early on, and I think the time we've spent the most rolling out to Aurora is just how do we solve the Ingress problem. Because especially with AWS, you don't get a lot of built-in support there with their ELBs. So yeah, so why did we use Docker, and why did we decide we had to go with that? Like I said, again, our Python applications have a lot of dependencies. Like I think the Docker image I have for our base Python has probably around 100 pip installs in it. So there's a lot of stuff, and some of it you can't even really install on the fly. Like we use NumPy and SciPy to do some of our modeling, and that takes probably 20 minutes to install and compile. So pulling that down as we launched the application really wouldn't be an ideal use of time. So we decided we needed a way to package these things together. And we also didn't want to have to install all these dependencies directly on the Mesos slaves, because that kind of defeats the whole purpose of what we're trying to do here if you have to go and reinstall everything anytime you deploy a new version of the application or something like that. So we went with Docker. We decided that was the way to go. And we decided that the easiest route forward would be to just add the support into Aurora. So that's what I had started working on around the end of November. Definitely coordinated a lot with a ton of the community. Like, you guys were awesome in helping us out with doing that. So landed some support. I'm not going to go through this a lot, but it's interesting, like, how much I got to touch going through this, and really learned a lot about Aurora. So like, we had to change the scheduler. fix, like, basically configure mount points in the Docker containers as they ran, just get the information into Mesos correctly. Some actual nice things that we added too is being able to pass command line parameters into the executor from the scheduler without having to have like question back there? Yeah, what's up? So why Docker containers versus pure LXC containers? Basically the decision we made was that Docker was a very well supported, kind of ingrained in the community product at the time, and still is, and it's being developed. So that was one of the big driving factors. The other big driving factor, too, is that it's supported by Mesos already. So we didn't have to do a lot of work on the Mesos containerizing side in order to support that. So then, I mean, other changes we had to make to the executor. One of the nice things, actually, that we use even for non-things is we allow the executor to not change the user that it's running as. So we can cause all of our jobs to run as the same user, which is sort of nice. Sort of insecure. And then again, obviously we had to change the client, so there's new structs and stuff in the configuration. I mean, here's a sample config, which I think really exemplifies how nice and simple it is to make a Docker job now. You really just add container to your config file, and Aurora and Mesos will handle the rest for you, which is very, very convenient. Migrating things into a container can be very simple, which we've done in the past where we had jobs that were running normally and then decided like, oh, maybe it would be better to just Dockerize these so we can have more control over it. So we can just do that pretty simply. One of the things I've been working on recently, especially for our Python applications, is the incremental deployment thing. And this is really where we get the biggest wins for our developers. So if I want to push a new image, I don't want to rebuild a 1.7 gigabyte Docker image, right? Like I want to be able to do quick incremental builds on top of it. So we built this process which basically takes the container, rsyncs our code base into it, then commits and pushes it, and then we can run a Aurora update over that. So the great thing about this is, I mean, like, how much Python code are we changing generally? Not that much. And this really allows us to do small, like 500K pushes. So I can iterate between changing some code and redeploying 90 instances in Aurora in like 5 minutes. So this is really where we're enabling our developers to make the most use of their time. They don't have to, question again? No, so we have our own private Docker registry. I don't think we'd ever want to go to the public Docker hub because it goes down like every 2 hours. Yeah, I'd encourage anyone doing this to run their own Docker registries and not use the public one. You could, but we use an internal one that we host on our own.
It's backed by S3.
Yeah, backed by S3, which I think we just use like there's an open source, like it's actually a Docker image that runs the Docker hub, which is kind of cool. But yeah, so I mean like the developer productivity I hear like every day from our developers. They're like, this is awesome. Like we can iterate so much faster. I think a great example is Dobermir has been tuning our Java better so that we could get it so basically lean and mean as it is now. And I think like if he had been having to iterate in the old world, as we call it, on our old system where it probably took 45 minutes to do a deploy, I think he probably would have jumped out a window. But we also probably wouldn't be where we were right now. It's just so awesome being able to iterate as quickly as we can now. And I hear it every day from our developers. So if people want to get started with this, and definitely encourage you to, because I think this is like a huge addition to the ecosystem that we have now for Aurora. There's some examples in the source tree. So if you look in examples jobs Aurora, or jobs Docker, there's a sample Aurora file that just launches a Python container and just executes a little shell script in there. You can take that on your own. The end-to-end tests have another good example of basically building their own Docker image and running that. And then mailing list and just IRC are great resources for this stuff. I'm always happy to help people out with this. So where are we going next? I think is the last thing here. One of the things that I think everyone can definitely admit here is that the integration between Mesos, Docker, and Aurora definitely is lacking. And we have a bunch of Jira issues open right now for this. There's not a lot of great error messages if pulls fail. Dobermir just came to me today like, oh, why does my job say it's lost all the time? And it's like, oh, well, you misspelled the Docker image name, and like you don't get any useful errors out of that. So that's definitely one of the things, and we've been working actually pretty closely with the Mesos community and getting patches in to get that working. Another kind of pain point is if you're pulling big images, you don't notice the tasks are actually pulling. There's no like intermediate state between assigned and pulling. So that's another thing that we really want to integrate better into Mesos and that we can use in Aurora. We want better integration with the UI also. Right now, because of the way Docker works, your process IDs inside of the container are different than they are outside, which kind of breaks the Thermos observer paradigm. So it's trying to monitor your process outside. It's like, oh, let's look at the CPU on process ID 5, and that's generally not a useful process. So you don't get great stats there. Although in the future, this might go away anyways, which will just kind of solve all our problems anyways. And then I think right now, we were just talking about this before, is removing the native dependencies in the executor. So right now, it gets a little tricky because your containers also need to be able to support running the executor itself. So if you have, I think we had someone that was trying to run a Debian image and had built the executor in Ubuntu, and there were incompatibilities between the libraries there. So having a pure Python executor would be a really big step forward on making this a lot more portable and easy to use. So we have on the plan moving over to something called Mesos, which is a pure Python implementation of the Mesos interface. And then I know something a few people have already asked me for is network mode, volume mounting, and privilege mode support for tasks, which, I mean, network mode would be cool if you want to run your task fully isolated. You could run it in bridged mode in Docker, which basically makes it so your container isn't visible from the outside world at all and gives you full port isolation and everything. Volume mounting, I know one of the big use cases is like, oh, I have this file with all my RSA keys in it or whatever. I have all my like secret passwords in there. I want it to be visible in all my Docker containers also. This would be a great way to solve that. So these are all kind of short-term things that I myself would like to work on soon, but definitely encourage anyone if they want to get started with some of this, talk to me, and we can figure out ways other people can work on this too. So I think that's about it. Does anyone have any more questions? I'm happy to talk more about anything in particular. I can elaborate more on what we're doing at TellApart and how we're using it. Yeah, what's up?
Do you do any resource pinning?
So the question is, are we doing any resource pinging? Or pinning, sorry. So yes, we are actually. One of the things we do here is the OR proxies are pinned to a specific, they're not to specific hosts, but to specific pool of hosts. The reasoning behind there is we want to isolate the network usage of those since they're probably the most high throughput of anything. So we want to keep jobs off of those, and we want to keep those off of other jobs. We're also starting to do pinned slaves on their own. So this job only runs on this one slave for persistent resources. I think in the future too, we're going to want to integrate a lot with, Mesos has some features now where they can do resources also for like hard drives and volumes and things like that. Anything else? Cool, all right, awesome. Well, thank you everybody for your time.